Hi there, here are some memory tricks for functional groups. The most common question that students get asked in National 5 Chemistry is that they get asked to name this functional group, and it's the hydroxyl group. And the most common mistake that they make is that they think it ends in OL. That's because alcohol ends in OL and methanol ends in OL, but actually it ends in oxy for oxygen, as you can see here, part of the word oxygen. So it starts with hyd for hydrogen, then there's oxy for oxygen, and then an L, hydroxy. Now I've got a very silly way of remembering carboxyl, and that is, I think of the car box aisle in a supermarket where all the car boxes are. I know it sounds a bit silly. Car box aisle. It helps me remember the spelling amongst other things. Box aisle. Make that one green. And then when it comes to the carboxylate and the carboxylic, the ion and the acid, I basically use the same approach. I think of a car, and then boxy. It's a very boxy car. And then lick. That's the carboxylic acid. And we also have a carboxylate ion. Carboxylate. I'll draw a carboxylic acid so as you can have a look at it. This is ethanoic acid. Has a double bond to an oxygen and an OH, and some hydrogens around there. And the reason that this is an acid is that it can lose a hydrogen, and that hydrogen goes off and becomes a hydrogen ion. That's the definition of an acid. It makes hydrogen ions, and it leaves behind a carboxylate ion. So that's carboxylate, this ion here. And the whole thing together with the hydrogen would be a carboxylic acid. Now my memory trick for ester, the ester link, is that ester is a coo. Ester is a cow. Ester is a coo. And my way of drawing esters is I draw it all around the oxygen that's in line with everything else. So if I wanted to draw this one, I would draw first of all put in the oxygen, and then I would put a methyl group, and then I would put an ethanoate group on the other side. Eth is 2 carbons, and as long as there's 4 bonds around every carbon and 2 around the oxygen, you'll know that you're getting it right, and then you just have to put in all the hydrogens. So my method for drawing these is that I draw everything around that middle oxygen. I always found these carbonyl group, the name of the carbonyl group, annoying, because I always thought it was an alkyl group when I first saw it, because it looks like it's carbon. Looks like you're sticking on some carbons. Oh, that's awful. So it looks as though you've got a chain of carbons and then you're sticking on another carbon, but no, doesn't mean that at all. It's all about the oxygen. This oxygen gets stuck on. In an aldehyde it gets stuck on at the end, and in a ketone it gets stuck on in the middle. So as you can see, there's an O in the middle of ketone, and that's where the oxygen gets stuck on in the middle. So there'd be more carbons going this way. And this one here, the oxygen gets stuck on at the end. So this one would be more like that, where the oxygen gets stuck on at the end of the chain. So there's an O in the middle of ketone, and there's an O in the middle of a ketone. Is a good memory trick for that. And just remember that it's not carbons that are being stuck on, because alkyl groups are when carbons get stuck on. So I'll just show you an alkyl group. Let's say you've got an alkane, maybe butane, and you stick on an extra alkyl. This is methyl. Make sure you've got 4 bonds around everything. Put in all the hydrogens. That would be an alkyl group. Thanks for watching. Bye.